An enhancement process for grayscale images resulted from image fusion. Abstract: many applications were introduced to do image fusion. The idea of image fusion is to fuse different images together to get more information from the images. In our application we fused a thermal image with a regular colorized image. The resultant image was in grayscale. In this paper we are introducing a system that take any image that has been processed using fusion algorithms in grayscale and enhance the image. The system can be used to improve night vision for navigation. This system consists of different stages: enhance, colorize, segment, restoration and fuse the image. The resultant image will have more information and will be colorized. After applying the proposed process, the results indicates the increases of the mutual information, MI, of the final images by 40% and in some images were more than that. Also, we made a comparison between two fusion algorithms, a simple algorithm that we introduced and shift invariant discrete wavelet transform, SIDWT, and we saw that our algorithm gave better results and was more suitable for our application. Keywords: image fusion, night vision, augmented reality, thermal imagery. Introduction. Darkness limits what a vehicle operator can see and causes an unsafe driving condition due to poor lighting conditions, such as driving at night and in bad weather, as well as poor visibility caused by human aging or illness. Improving night vision capability will increase the safety of nighttime vehicle navigation. Ideally, a system that can enhance low visibility situations and poor lighting conditions, such as driving at night, and make it appear as if they are happening in daylight. There exists many systems that help the vehicle operator in low visibility situations and poor lighting conditions by using thermal camera. These systems can identify any warm objects at night, for example identifying animals and pedestrians 1-2. By using the thermal camera this will distinguish warm objects and it can be displayed on screen and also it can be segmented. Also the use of augmented systems will help in these kind of situations by identifying lanes and signs. These systems may be used for various applications such vehicle navigation, surveillance, and monitoring applications to improve safety. The idea behind these systems is to provide the user with an image that is easy to interpret. Using these kind of systems is helpful but they concentrate on a special situation. So the need of a more general solution is wanted that can address different conditions. Various night vision systems have been developed to improve the ability to see at night. 3, 4, 5. Thermal cameras respond according to temperature, but they provide only limited data to describe a scene. Adding additional sensors has been one traditional approach to this problem, and combining images using these sensors can enhance the results. One of these fusion systems was a system that we introduced before 6. It is a simple fusion algorithm that which uses pixel values from the thermal image and the database depending on a threshold. So the information from both fused images are important but the real-time image, thermal image, information is more vital because the warm objects is the main concern but it will give us more vegetation areas. Results from this system will be used for the introduced enhancement system. In the following figure the original images that has been used for the image fusions. Objectives. The introduced system objective is to take the resulted fused image from the fusion algorithms that has been used as an input and enter it to the system that will enhance, colorize, segment, restoration and fuse the image. This will add more information to the image, decreases the area of vegetation and increases the mutual information, MI, of the image. The paper will start with the methodology where the introduced process will be discussed as a whole and results will be given. This will work as a summary for the new process. Then the following sections each stage will be introduced and discussed. In each section the algorithms that has been used is introduced. Methodology. In the resulted images from the previous algorithm the introduced system will remove any areas of vegetation without losing information from the thermal image and increase the mutual information of the images. This will allow us to have an easy to interpret image with all important information from the thermal image. This led us to develop a procedure that will help us get improved results. The process consists of 6 stages which are image fusion, colorization, segmentation, colorization of the most important cluster, restoration from clusters. Image fusion. In this section we will use 2 fusion algorithms, the simple image fusion algorithms and shift invariant discrete wavelet transform, SIDWT. The fusion algorithms will get enough information from both the thermal images and the daytime images. Fig 7 shows the fused image using the simple algorithm and Fig 8 will show the fused image using the SIDWT algorithm. Fig 7, image fusion results of simple algorithm, A, scene 1 far pedestrian, B, scene 2 far pedestrian, C, scene 3 far pedestrian. Fig 8, image fusion results of SIDWT algorithm, A, scene 1 far pedestrian, B, scene 2 far pedestrian, C, scene 3 far pedestrian. Colorization. In this section a grayscale image to red, blue, green, RGB, image converter will be used by using the colors of the reference image. The algorithm can be described in these following steps. Convert all images to YCBCR color space, where Y is the luminance component, CB is the blue difference and CR is the red difference chroma components. Use jittered sampling to select a subset of pixel in the reference image. By using the jittered sampling that will divide image into grid and randomly assign 1 pixel to each grid. Find a pixel in the grayscale image that best match the sample in the reference image. We can determine the best match if the 2 pixels in both images have similar luminance and standard deviation. The chromaticity values, CBCR channels, of the best matching pixel are then transferred to the grayscale image to form the final image. Convert the final image to RGB from the YCBCR color space. The better the destination image match with the source gray image, the better the coloring will become. This step is needed for the following step, segmentation. Some examples of the colorization process will be shown in Fig 9 and Fig 10, which is the colorization of the images in Fig 7 and Fig 8. Fig 9, results from Fig.7 colorized. A. Scene 1 far pedestrian. B. Scene 2 far pedestrian. C. Scene 3 far pedestrian. The colors of the new images look alike for both algorithms because we used the same image as a reference image to preform the colorization. Segmentation. In this process we will use k-means clustering algorithm with k equals 3. Colorization of the most important cluster. In this section we used the same colorization algorithm that we used in step 2. Also, from step 3 we will color cluster C of each image, because cluster C is the cluster that contains the most information. This step is required because we needed to enhance the cluster for the restoration. This stage gave a small improvement but we used it because in the restoration step it gave pixels that are different from the original clusters. The resultant image is shown in Fig 17 and Fig 18. Fig 17, colorization of cluster C. Simple algorithm colorization of cluster C. A. Scene 1 far pedestrian. B. Scene 2 far pedestrian. C. Scene 3 far pedestrian. Fig 18, colorization of cluster C. SIDWT algorithm colorization of cluster C. A. Scene 1 far pedestrian. B. Scene 2 far pedestrian. C. Scene 3 far pedestrian. Restoration from clusters. In this section we restored images from the clusters. Step 3 produced 3 clusters, cluster A, cluster B, and cluster C. Therefore, when restoring the images we will try to retrieve cluster A from the source thermal image, retrieve cluster B from the source daytime and retrieve cluster C from the colorized image in step 4. We did that because, looking at cluster A, usually it contains the warm stuff. Looking at cluster B, usually it contains backgrounds such as trees and roads. Looking at cluster C, usually it contains more pixels than the others. Discussion of results. Results show that in the first step we got a fused image in grayscale and in the sixth step we got a fused image in color with a higher value of MI. Fig 23 shows the MI of the first step of the process and Fig 24 shows the MI of the last step of the process. We can see that we have an increase in the MI about 40 present and more in other images if we compare between the first step and the final step. That shows that the proposed process gave better results. Different results were found by the simple algorithm and the other algorithm such as SIDWT. Some of images gave better results for the simple algorithm and some gave better for the other algorithm such as SIDWT. Fig 23, First Fusion. Conclusion. An image fusion system were developed that can lead to improved safety for nighttime vehicle operation. The use of a public database gives results not possible with other approaches. We found that by giving the database image priority over the thermal image, the fused image appeared the most daytime-like and easily showed a pedestrian. As the priority of the thermal image increased, the background of the image was formed by both thermal and database images. A. The process consists of 6 stages which are image fusion, colorization, segmentation, colorization of the most important cluster, restoration from clusters, image fusion. After adding this improved process we were able to better visualize the images. They become more realistic because some vegetation was introduced. This was supported by an increase in the value of the MI after adding this process by 40 present and more. In the end we can say that we were able to make driving at night comparable to driving at daytime.